Hello, everyone. Hopefully you can hear me. My name is Joe Beeton. I'm a staff security researcher at Contrast Security. I used to be a Java developer, and I was one for 10 years. I still do a bit of Java development. And then I got a bit bored of that, moved to application security. And I've been doing AppSec in one form or another for around 6 years. Just a quick thing, plug, work with Contrast Security. We make IAST and RASP and other AppSec tools, static analysis, stuff like that. Yeah, let's get started. So this began a few years ago. I found a few vulnerabilities in a web framework called Toggles. They weren't that interesting. There was XSS and CSRF vulnerabilities. I worked with the maintainers of this open source product to fix it, and that was fine. So Toggles was, still is I suppose, a web framework for creating something called feature toggles, which is a development design pattern to allow you to deploy to production systems or features of an application that you may want to enable for a short time or enable for like 10% of the customers to your website, and then you're able to roll back if it doesn't work as you expected. And had different ways of setting up the kind of switchover. So like a certain percentage could be going to the new version, or IP ranges, or lots of other different things. And one of the custom rules was that you were able to modify in the web, in the UI JavaScript that would take the web request, pass it for certain things, and based on that, send you to the new or the old version of that functionality. And that becomes useful later on, because that JavaScript was executed inside the JVM of the web application, and so that is very useful. But in the real world, it was a CSRF and XSS vulnerability. To use the CSRF vulnerability, you would need to know that A, they were using toggles, and so if it was deployed to production, it should be behind some sort of authentication. But you'd need to know the location on the production server to be able to get get that user to make that change. And you'd need to know the name of the enum. So it would be very difficult to create a real-world CSRF attack from it. It's realistically hard to do. But yeah, that was it. Fixed the issue, but it kept bugging me, especially because of the potential for remote code execution with the JavaScript running in the JVM. I kept thinking about it. And about the same time, there was a few news stories, tech news stories, about being able to run from JavaScript in the browser essentially a port scan into your local machine or your local network. This used something simple request attacks. They're very limited in what they can do, and this scanner was using it for essentially how it would work is you can make the request, only get to a post, and only very, very limited, but you don't get the response. The JavaScript in the browser gets an error code back from the browser, and it can infer based on timing what if it's hitting a web localhost port 1234, if there's a service behind that based on the timing. If it returned immediately, nothing there. If it took a bit longer than that, there might be a service, and that's how it worked. And this was used by eBay, I think was the main user.
To interrupt, if you could just hold the mic closer.
Closer. Oh God. Okay. Well, hopefully people could still hear what I said. Anyway, this was used by eBay, and I think was the main user. I'm sure other companies use it as well to fingerprint users as part of the way they fingerprinted users going to their site. For some reason, they thought that port scanning their local machine of their customers was a good idea. They don't do it anymore, I don't believe. Anyway, so simple requests are very limited. but this is very important for the rest of the talk. You could only make, from JavaScript in the web browser, head, get, or post, only content type of application, multiform data, text plain or null. Null or nothing in the concept. So you essentially don't set a content type header within the JavaScript. And only a few other very limited headers are allowed. If you try and set any other header, it becomes a normal request, and that goes through the regular pre-flight checks. So no auth tokens are allowed really in a header, no cookies, anything like that, not allowed. So most requests wouldn't fall under this. So this is what it looks like if you were to make that kind of request in the browser. It's the Firefox Dev UI. You don't get a response from the browser. Either it doesn't respond, it just times out, or I think in Chrome you get an error response. So you really get very little. You get no response back. So even when the server you're accessing responds, it gets to the browser does not return that information back to their JavaScript. So if we take a look, if you make a normal request, before you can make a normal request from evilexample.com to localhost, it would require a pre-flight. The pre-flight would call HTTP options, and only if it had a header with access control allowed, localhost or star or whatever it is, would the browser then allow the JavaScript to make a follow-on request to localhost or any other system. But for simple requests, you don't get that. It goes straight to HTTP post get options. Although options isn't really used for any of this. And it returns, but not readable. But it does get to that localhost service, and that localhost service, depending on what's there, you can then make some sort of state change. So for toggles, I crafted this lovely JavaScript. So what this does is it will call localhost / toggles console. This is an attack where you're assuming you're going after a developer, where that developer is running their web application and they've got the toggles console enabled, no authentication because it's bound to localhost, so why would you bother? No one else can access it. And it makes a change to one of the toggles. And what this will be doing is setting the toggle to essentially run some JavaScript, which is in the browser, and that browser is in the JVM, and that JVM you can run anything. Even when you're running JavaScript, you can actually execute Java code because it's all running within the same JVM. And what I'll be doing, what you'll see is, if I can get, it should. Cool, okay, so this is the toggles console. You don't need to know much about this. All of the demos will be available on GitHub. But this is the one. Problem is I can't see this, so it's quite difficult. So this is the web page with all the different payloads. So if you go to toggles, click this link, what will happen is it will load essentially a page with that JavaScript. And unfortunately, it's popped up on my screen, so you can't see it, but it's popped out the calculator. So if you are a toggles user as a developer, you could, as an attacker, if you could create something like a toggles how-to tutorial, they would download toggles as part of the web application, run it, and in the background of the toggles tutorial website, you could have JavaScript doing this, not popping a calculator, but obviously something else. So we have that. And as you can see, if I hit refresh, we should now see this is the code that was run. Runtime exec open calculator. So that was the first one. Again, for toggles especially, this is quite limited. You need to know the enum name that you're going to change. The enum is the feature toggle name. You need to know it. And there isn't any default ones. They get configured by the developer as they set up the system. So you would either have to guess, or more likely, you build some sort of website that someone who is developing a web application with toggles would want to visit, like some sort of tutorial website. Add some JavaScript, and that's it. You can take over a developer's machine. Or if you could create an advert that uses toggles as a keyword, and if that advert allowed it, embed some JavaScript in it, and when they search for toggles, they get the advert. And again, you can start accessing the system that way. So yeah, something like that. So after that, I realized that there are quite a few different frameworks that do this kind of thing. It's a very common kind of pattern where developers will, because it's down to localhost, they won't have any sort of protections on their system because, well, it's just localhost. Why would you? So I'm sure anyone who's done any Java development will know about Spring. It's essentially the de facto standard for web development in Java. And Spring actuators are a feature of Spring where, when enabled, they add some endpoints at set points within the application. And those actuators, or endpoints, do certain things. Most of them are fairly innocuous, or don't make any state changes. So /health returns a 200 if the application is healthy. Env is a bit iffy. I'll go on to that later on. Trace isn't great to have deployed anywhere else, but in localhost it's not too bad because it just returns a list of HTTP requests. Heap dump does what it says. It dumps the memory to a file and downloads it to the browser. But again, as you can't see that from a simple request, it's not that useful. But there are a few that do change the application state. The environment does sometimes. It depends on how it's configured, not by default. Restart, reload, and shutdown all do. And the thing so the first one is one that's fun to annoy a developer, but it doesn't really help you that much. It's under the endpoints will be under /name of actuator like shutdown or /actuator/shutdown. So this payload checks both. The fun thing here is it actually requires a content type JSON, but because the post request doesn't require a body, the Spring actuator doesn't actually check the content type. But all the other actuators which do have a request body require JSON, and even in the code it says that, but because there isn't any content type, it doesn't check the body. And it doesn't check the content type header, so you get away with it. So you can make a post request and shut down the developer's web application that they're developing. Again, it'd be quite annoying, but not that useful for an attacker. So that was with essentially that works in any version of Spring. You can do that. I did talk to, well, at the time it was Pivotal security team. Then it was VMware, now it's Broadcom. I think it was the Pivotal team I talked to. They've been bought out many times. Anyway, but there was an earlier version of Spring Actuators which you could make changes to and didn't require a JSON endpoint. So it's Spring Boot 1. This is very old, and this is end of life in 2019. Spring 1. You require that. You require Spring Cloud dependencies to allow for, and that gives you the ability to modify the environment variables of the application via the env actuator. A H2 database, and you need to be able to restart the application because once you change the properties of the application, you have to restart it for those changes to take effect. But with all of that there, which would be realistically very rare, although I have seen it a few times, you can do something like this. And so what this does, it makes a post request to the env actuator to modify the JDBC URL, so where the application's database URL. What this will then do is set it to use the internal memory database, H2, which is a built-in database used by essentially developers. It's built into the memory of the application. It can be a flat file. It's not used in production, but it's useful. It's it's widely used by developers, I should say. And so what this will do, set that URL, that database URL to localhost to H2, which when you do that, if you have the H2 library, it will start itself up in memory. And then on startup, it will then load a SQL file. The database will then pull down a SQL file from, in this case, some random site, and then that will execute some SQL on startup of the database when it gets restarted by the restart actuator. And this is what the SQL code looks like. So H2 is the memory database, and because of that, you can execute Java code from within it for some reason that I've never been able to work out, but it's useful for me. So again, what we can do, if we run a demo, yeah. So go back. So this is a Spring 1 application. Click the link, and hopefully eventually okay, well, that didn't work. Trust me, it does. So what this should have done is set the properties of the Spring application, restarted the application, and made the change. Live demos. But pretend a calculator opened up on the screen. It worked in testing. Okay. So, should now. Okay, so the application's back up. Okay, that didn't work. Let's just kill the application. So I hit the shutdown actuator payload. So now when I hit refresh, at least this should work. It did. Great. Phew. Okay. So that one worked, at least. Okay, let's get back to the demo. Okay, so that was Spring. Then I moved on to Quarkus. It's a Spring-like framework, similar to Spring in many ways. Even the syntax of the code looks pretty much the same. Again, created for web applications and APIs, things like that. So this is the code. If you know what Spring looks like, that will look fairly familiar. It too has a web UI. This one is deployed by default, so no weird extra libraries required. And that library lets you modify the configuration. So hopefully this time it will work. This is what the payload looks like through the web UI. Again, we're just making a change, exactly the same class of attack as last time. H2 database. Modifies the configuration of the properties, JDBC properties, restarts the application, and then hopefully loads it. I don't have much luck. I'm going to cross my fingers. But, okay, so. So this vulnerability, I worked with the Quarkus team, security team, Red Hat security team, it's owned by Red Hat, to fix, and it took a while to get them to understand what the issue was. But once they did take it seriously. It got a CVSS score of 9.8 or 9.7, which is the highest score of any vulnerability for Quarkus to date. So let's see. Okay, so this is their UI. Go to config editor. So this is what we're going to be hitting. Currently, it's using in-memory database as well. This is, by the way, the Quarkus liquid-based quick start tutorial. It's part of the main Quarkus kind of GitHub page. They own it, and I was able to use that to show them the issue. So it doesn't require any extra weird stuff. It can happen on essentially any base Quarkus installation. So let's see if this time it works. Hey! So here we go. Again, this is basically the same thing as what was happening in spring, but this time it worked. Again, so what happened is the H2 database was restarted. It downloaded the SQL file, which contained the malicious Java code, which is then executed to wake up a calculator. So yeah, it was fixed in 2.14.2, which came out end of last year. They did take a bit of convincing, but after a while they worked it out, and it was fine. So now for the new one. This is the last one. So this is a different kind of issue. Well, a request attack, but not remote code execution. This is MLflow. MLflow is a machine learning training framework. I reported this to them in, I think it was either late August or early September. On GitHub, I got a message back saying they're looking into it, and then nothing. I even told them on September 5th I'll be making this public today, and so here I am. Still not fixed. But here we go. I have emailed them and messaged them on GitHub many times, and they've still not replied. So you can probably see where this is going. MLflow has a web UI, where you have a machine learning model. You can train it, and as part of that, there are hooks using MLflow to send that training data and other information about the training of that model to their system, which is usually saved to local disk, but not always. You can change that. And that will get that. You then train the model and then do stuff with it, I guess. And that's the location of it, localhost port 5000. So yeah, it has a web UI. It has a REST API which uses JSON. Content type JSON shouldn't be vulnerable, but you can change. You don't need to set a content type. Well, you do, but it doesn't care. It doesn't check. So if you set the content type to text plain, you can perform the same class of attack. So when you have these machine learning models in this system, you essentially create almost like folders. They call them extensions to do that kind of training in. And you can, using this kind of attack, you can change that. So, and those are then usually pointed to a location on disk where all that data then gets saved off to. But you don't have to. So as it comes, it starts out with an extension called default, which has an ID of 0. So you know what the ID is, which is useful. Then what you can do, you can't delete it. You can't delete the original one using the API. But you can change its name to old, then, which is what the previous slide did. If you take a look. So we've renamed the experiment with ID 0 to old. Then we're creating a new default, and we're giving an artifact location of an S3 bucket that you control. It has to be globally writable because they won't have the credentials to access it otherwise. But you do that, you can then essentially start controlling where that data. You have access to their data, the machine learning model and training data, and other stuff. So yeah, the attack changes the default location. It changes it to a name old, so they stop using it. Create a new one called default, so it looks the same. And as long as they don't take a close look at what the artifact location is, you then have access to their training data and model. And this is what the AWS S3 web UI looks like once you've done that. I did this a couple of days ago. I'm not going to do that live. I would have to make it globally readable and writable. I don't know what you'd all do in the time it takes me to put it back again. But there you go. So. Oh, wait. So this is what the UI looks like. Some old data in there from a previous run. Take a look. So this is the information that gets saved to whatever your artifact location is, in this case S3. So you have information about training data, other information. You also have a pickle file, Python pickle. So you can then modify that and then potentially cause a deserialization attack on their system when they reload that model, and from there, remote code execution on their machine. So if we do a quick demo. So if we take a look, so we go back. So this is the payload location. And hopefully, if I hit refresh, we should see that default has been renamed old, and there'll be a new default. Oh, come on. What does it? Okay, it's renamed it old, but it's not giving me a new one yet. Let's hit refresh again. There we go. Don't know why that didn't work last time. So we now have a new default location with an S3 bucket that you can control, and from there start siphoning off their machine learning data and models. Okay. So let's go back. So I did try and tell them several times, 7 or 8 emails and several times on GitHub, last time yesterday, and still no reply. So obviously this is going to be published now, and hopefully they will then fix the issue. It's relatively easy to fix. Just check the content type of your API. Because what I can't send a JSON request. I can only say text plain, but they don't care, so it works. Anyway, so this is an attack There are ways to fix this that aren't browser-based, but changing how the browser works is the best way of doing it, because people aren't going to stop using insecure web UIs bound to localhost. Any sort of auth would fix this, wouldn't be able to do this. Any sort of CSRF token, again, would stop this from happening, but there we are. Luckily, there is a RFC W/W3C spec that will solve this class of problem. It was originally meant for Chrome 101, which was last year in December, I believe, and it got pulled because it caused issues. So there are things that effectively rely on this system to work, these kind of simple requests. And so putting in a fix breaks those. And so they've tried to deploy this change multiple times, and it keeps getting pulled. I'm not sure when they're going to fix it. But to give you an idea, so the actual fix is called private network access. So if we take a look. So if you had a simple request and you're going from what's classed as a less secure network to a more secure network, which would be the internet to localhost, or the internet to a internal network, or the internal network to localhost, you would have to make a pre-flight request. The browser wouldn't let you not. And not just any, there's a new header to go along with it. So before you could make that request from the browser, you would have to set this header, and only if the web application returned a header saying true, it would then allow you to make the original HTTP request. That would effectively block this class of attack completely. But when they actually get around to doing that in Chrome, I don't know. But that's Chrome. Well, Chrome, Chromium, Edge, and any other Chrome-based browser will get fixed when this gets released. Firefox has it on their backlog. I think they're waiting to see what Chrome does and for them to fix any kind of compatibility issues before they make any changes. So IE, it works on IE, but that's never going to change. It's dead. Safari is the only main browser anyway, that doesn't allow simple requests and doesn't seem to ever have done. Not sure why, but that's where it is. Developers will always assume, and most people really, that anything bound to localhost is secure. Only they can access it. And that's not, until those browser changes are made, that's not the case. And this is an area where there are lots of vulnerabilities. And so until Chrome and Firefox fix this class of issue, there are lots of frameworks that I've not looked at yet that will have similar issues to these. If you're interested in this kind of thing, it's quite a fruitful area to research. You will find things, I pretty much guarantee it. And that's it.
Thank you so much. We already have a contender here for questions. We're going to take 2 or 3. And you at the back, please come in. There are plenty of seats over here. You don't have to cram in there. Come up to the front.
Hello there. Based on this presentation, what are the best practices that we can use as developers to not get in this kind of attacks?
Sorry, as developers writing these kind of frameworks, or just developers generally?
Generally.
There are things you could do. First of all, make sure your frameworks are up to date. Hopefully they fix these kind of issues when they get reported. Not always the case, but you can hope. If you use something like Docker, that will help with certain classes of attacks anyway. That's an extra layer of security around your web application. Apart from that, as a developer using these frameworks, there isn't much you can do. Don't use Safari. It's probably, it's probably, until that gets fixed, I think it's probably the only other solution you have. Because you're going to look at websites, you're going to look at tutorial websites, especially. No one can stop you. So yeah, use Safari.
Okay, so until the browsers are fixed, we will have this issue on.
Yes, once the browsers are fixed, this issue goes away.
Okay.
And they're the only people who can effectively fix this. They can fix it globally. As a developer, even fixing a framework, you fix it for your framework, which is great, but not for 1,000 other frameworks.
Okay, thank you.
Okay.
Okay, cool. Any other questions? One over there.
Are there any known exploitation of this vulnerability in the wild?
Not of these, no, not that I know of.
Okay.
Not that I know of. It doesn't mean they haven't happened. I'm not the first person to come across this.
But I assume
Why is
once
that?
you publish this, there will
Well,
be...
I've done this talk a few times. Not with the ML flow, that bit is new. But the Quarkus issue was fixed late last year, and we talked about it then. So it's a known issue, and other people have essentially come across it in the past. There was I'm not sure why the link doesn't come up, but there was a Redis vulnerability in Redis, which had at the time a HTTP web service built into it. And there was a vulnerability that allowed you to escape the Lua interpreter, and he patched it using this technique. So you clicked a button on his blog, and you hoped he wasn't doing anything nefarious, and he would modify the Redis installation itself, because you get execution on it, to patch it, so it fixes the entire issue. So other people have come across this class of issue before, but I don't think it's been looked at, especially as a way to attack developers in this way.